Hello, today we are looking at an introduction to derivatives. The derivative represents the instantaneous rate of change of y with respect to x at the point. So now we need to talk about what does that mean. So rate of change. The rate of change is also the slope. So what happens is that the derivative is helping to give us the relative slope along a curve. So relative slope along a curve. So what does that mean? So if we were to take just a general curve, okay, so here is some sort of like x cubed sort of equation. And what ends up happening is if we were to choose some points on this curve, and drawn the tangent line. So a tangent line, as a reminder, is a line that touches a point or touches a curve in one point. So a tangent line will touch a curve in only one spot, or in only one point. So with our point that we have here, our tangent line is going to be drawn down here at this point. So, but if we were to take another point along the curve, let's say this point here, and then find the slope of this line, it's easy to see that our two black lines do not have the same slope. Well, the derivative helps us to figure out how we can identify what the slope is at all different locations along this line. There are quite a few different ways to find the derivative. We will be working with one of them today. So the formula for derivative that we're going to be working with today is the following, and it says that, so if we just read this, the tangent line of a graph y equals f of x at the point a comma f of a is the line through the point having the slope of the limit as x approaches a of f of x minus f of a all over x minus a. This provides that the limit exists. If the limit does not exist, then there is either no tangent line or a vertical tangent line at that point. The slope of the tangent line is also called the slope of the curve at the point and corresponds to the instantaneous rate of change of y with respect to x at that point. So now let's take a look at this example. So what we're going to do is we're going to do two different things. Right now we're just going to work on finding the slope. On the next slide that I show you, we're going to be looking at finding the entire equation for the tangent line. So we're going to find the slope of the tangent line to the curve at the given value of x. So what I'm going to do is I'm going to graph f of x equals x squared. Now when you go to do the homework, you will not necessarily need to graph that, but f of x equals x squared, that's one of our standard graphs that we should know how to graph. It's a parent graph equation. So if I was to just go ahead and sketch this, we know that f of x equals x squared is a parabola. It's going to go through 0, 0, and then 1, 1, and then 2, 4, then negative 1, 1, and negative 2, 4, and it's going to be a curve that looks like this. So now what we're looking at is when we want to find the tangent at x equals 2, and why are we choosing 2? Because that value was given to you. We're going to go over to this point, which we've already calculated was at 2, 4, and we're going to say if we're going to draw in that tangent line at that point, then what is the slope of that line? So we are going to use the limit as x approaches a of f of x minus f of a over x minus a. So what's that going to get us? Well, it's going to get us the limit as x approaches a of x squared minus 2 squared, because our a value is 2, and we can put that in place of the x, and we get the 2 squared over x minus 2. We're now going to simplify this. So as we simplify this, this is going to get us, and actually, let me go back. The limit is not going to be as x approaches a anymore. It's going to be the limit as x approaches 2. And this gets us x squared minus 4 over x minus 2. Now, from what we did before, we know that in this case, we're not going to be able to use direct substitution. So that means we're going to have to do some factoring. So we're going to say the limit as x approaches 2 of x plus 2 times x minus 2, because it's a difference of squares, over x minus 2. Now the x minus 2 on the top and bottom will cancel. That's going to leave us with the limit as x approaches 2 of x plus 2. So now we can put the 2 in there, and we get 2 plus 2, which is 4. Now all of this was finding the slope of our tangent line. So that means the slope of this line in green is 4. The slope is equal to 4. Now there's no correlation between the slope and the y value. It just happens in this example that they are exactly the same. Now with our next example, we are going to write the equation of the line tangent to f of x equals x squared minus 2x at the point x equals -1. So we are still going to use, we still have to start by finding the limit as x approaches a of f of x minus f of a all over x minus a. That is the equation that we need to use to find the derivative, which gives us the slope. Now I'm going to do a few different things at the same time here. First off, I'm going to graph this. Now, if you don't know what this graph looks like, one, you can make a table. The second thing you can do is that you can go to Desmos and use that to get the values. What I'm going to do is just factor, because if we have x squared minus 2x and we set that equal to 0, factor out the x, we are going to get that our graph crosses the x-axis at x equals 0 and x equals positive 2. So at x equals 0, it's going to cross, and then at x equals positive 2, it crosses. Now our vertex has to be halfway between the 2 points where it crosses the x-axis. So our vertex is going to have to be when x is equal to positive 1. So if I put positive 1 into this equation, I'm going to get 1 squared minus 2 times 1, which is 1 minus 2, which is -1. So that means our vertex of this equation is at 1, -1. So at 1, -1, I can have that point there. I can then get a few more points, and realistically, we are going to need the coordinate. So we are going to need the coordinate specifically when x is at -1, because we're going to be using that to find our tangent line. So that means we need to find f of -1. So f of -1 is going to get us -1 squared minus 2 times -1, which means positive 1 plus 2, which is 3. So we're looking at the coordinate -1, 3. That coordinate is going to become important when we go to actually write our tangent line. But -1 and then positive 3. And the thing about parabolas is they're symmetrical. So since we went over 1 and then up 3, from this other point we can go over 1 and up 3. So that's going to give us the curve that looks like this. Okay, so all that is set and ready to go. So the one thing I want to look at is the fact that if we are looking at the point -1, positive 3, and we look at that tangent line, it's pretty clear to see that our tangent line is going to have a negative slope. So we are now, so again, all of the graph you can get off of Desmos if needed. Okay, you do not need to necessarily draw the graph and do all that stuff on your own. Use Desmos, get the graph. You could probably even find your exact coordinate off of Desmos as well. But if you need to find that, again, you take the value you are looking at and you substitute that into the equation. All right, we're now going to go ahead and use our tangent or our slope formula, our derivative, to help find that slope. So that means we're going to do the limit as x approaches -1, because that's what our a value is, of f of x, which is x squared minus 2x, minus our f of -1. Well, luckily over here, we already found what our f of -1 is, which is positive 3. So then minus 3 over x minus -1. So what does this get us? The limit as x approaches -1 is, or of, not equal to, Well, we end up with, we have to factor the top. So two numbers that multiply to be -3 and add to be -2 are going to be -3 and +1. So that gets us x minus 3 times x plus 1. Our denominator is x plus 1. This is nice that those two values cancel out. So that leaves us with the limit as x approaches -1 of x minus 3. We can then put x minus 3, or put -1 in there, and we get -1 minus 3, which gets us -4. So now the slope of our pink line is -4. So our last thing we're going to do is we are going to use our slope of -4 and our point of -1, 3, and we are going to use this information to write the equation. So the equation of the tangent line is going to be y minus y1 equals m times x minus x1, which is our point slope form, which would be y minus 3 equals, our slope is -4 times x minus -1. So y minus 3 equals, the two negatives now become a positive and do the distributive property. So -4x minus 4. Then we can add the 3 to the other side, and we get y equals -4x minus 1 is the slope of our tangent line. Now, if we take that slope of our tangent line and look back at our graph, well, even though it was just a sketch, it does look like we are getting close to a y-intercept at -1. So our pink line actually has the equation y equals -4x minus 1. So that gives us the tangent to our curve.